All of this is prelude to like actually connecting to a peer. Right?
It's exhausting.
I know. But once you actually have a connection to a peer, now I have to send data. Feross talked about like the difference between TCP and UDP, right? And TCP guarantees that I get all these packets and UDP doesn't. And there's actually an algorithm and a protocol for deciding how to retransmit those packets and when to retransmit those packets. And it ensures that all of them arrive. So the cool thing about doing this on top of UDP, right, is that if you're streaming video and audio and you've actually lost the connection, you can say, don't bother sending me all the things that I already dropped. Just like, please just start sending me the new thing.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by Rollbar. Move fast and fix things. Resolve errors in minutes and deploy with confidence. Head to rollbar.com/changelog. Request a demo. Get started today. It's loved by developers, trusted by enterprises, and most of all, we use it here at changelog. Move fast and fix things with Rollbar. Once again, rollbar.com/changelog.
Welcome everyone, this is JS Party, your weekly celebration of JavaScript and the web. We have a good one for you today. Suze, Feross, and Mikeal dropping WebRTC knowledge bombs on me. Next week, Mikeal returns with Fred K. Schott for the latest on ES modules. After that, we're talking Node best practices with a special guest and a special new panelist. Stay tuned for that one. Okay, let's do this. Hey, it's party time, y'all. Hey, it's party time once again. I'm Jerod, I'm your friend. Shaboy! And I'm joined by three of my friends. Suze Hinton is here. What's up, Suze?
What's up? It's good to be back.
Great to have you. And Feross is back as well. What's up, Feross?
What's going on, everybody?
Here for the WebRTC, and Mikeal back from the dead, or back from where have you been? You're here, but where have you been?
I don't know if you heard about this, but there's like a huge virus. What? It's got everybody stuck at home. It's like a big thing. Yeah.
We've had a long time request to talk about WebRTC. Now, it's not the first time that we've done WebRTC on the show. It comes up from time to time, especially when Mikeal was a more regular panelist, and Feross as well. However, full disclosure, I know very little about WebRTC, so I always felt like, what's the opposite of imposter syndrome when it's actually accurate? I don't know. I just couldn't do a show on it because I didn't have the expertise, and I was not about to go and acquire it. Instead, I waited for you three to all be available at the same time. I had some actual WebRTC folks with lots of experience and insights and intuitions, and so we're going to treat it the best that we can here today. First thing we're going to do is just define it, give a little bit of the history, and lay the groundwork, followed by some projects that use WebRTC, take good use of it, hopefully to inspire and to show just what's all possible, because it's a very powerful API. But who's got the background on WebRTC? I know it's been around longer than I thought it has, which is 9 years ago was the initial release, 2011. Does anybody know the history or where it came from and how it came into existence?
I can take a stab at that.
Go for it.
So I first heard about WebRTC in 2012. It was experimental new browser API for letting you do peer-to-peer connections in the browser. So that means that instead of the normal way that the web has always worked, which is to have client server, where your browser connects to a server, with the fetch API or something like that and asks for stuff and the server responds. It's an API that lets you for the first time connect a browser to another browser. So my browser on my computer can connect directly to your browser without going through a server. And then, that gives you better performance for things like video and voice calling. And so that was sort of the impetus for WebRTC was, a few big, video and voice vendors wanted to basically have the ability to do something like a Skype, but from your browser. So the ability to do voice and video calling. And so that was sort of the impetus for the development of WebRTC. Mm-hmm. So, how can we do that without having the user install something on their computer?
In the same way that, YouTube and applications like that really push the browser to implement the video element and not rely on these external plugins. The use cases around real-time talking to people and having video calls really drove the WebRTC use cases. So much so that when it was initially released, it didn't actually have a data channel. It was just video and audio, and we kind of had to fight to get a data channel in there where we could just like move data around peer-to-peer. It was somewhat of an afterthought, and it's noticeable.
So it was initially came out of Google, who acquired a company called Global IP Solutions in 2010, which is a video conferencing company. Now it's supported by Apple, Google, Microsoft, Mozilla, Opera, et cetera, et cetera. Curious why internet giants such as Google, such as Microsoft, such as Apple would want to invest in a technology that removes servers from the equation when there's so much in the middle of many of our conversations. Is there like altruistic reasons for this? Are there strategic reasons why Google would want that to be the case? Just asking, I mean, you're obviously just conjecture at this point, but.
I mean, it's hard to find a server that is directly in between n number of people. Finding the optimal path between a bunch of people to do something in real time is actually a very hard problem to solve if you're routing everything through a central server. Mm-hmm. So it's actually just more efficient a lot of the time, especially if you're doing something like real time, to talk directly peer to peer. And so, like all of the early Skype stuff, and especially like when WebRTC came out, Skype was all peer-to-peer, and it was sort of the best that we had for real-time audio over the internet.
Yeah, I mean, the simplest explanation is that, if I'm calling somebody, I'm in California, and they're in California, the fastest path is directly with as few hops as possible. We keep that connection completely in California. But if you're like forcing everything to go through a server, and that server's in Virginia, right? Now you're sending this video data all the way to Virginia and all the way back to, maybe your next door neighbor who you're calling, and it's just less efficient. It's going to lead to more latency. And when you're doing real-time communications, every little bit of latency affects the quality of the call.
Mm-hmm. And so much of the cloud is in Virginia. That's where the cloud lives, isn't it? Virginia? Suze, you're going to say something?
I think it's just, it really has allowed companies to save money. It's made them able to offload bandwidth as well, which gets very expensive and very challenging and to scale. But also they can deliver a better product because users aren't going to sit around and go, well, real time is hard, so I understand why my video is really janky. That's not something that they should ever have to really be empathetic about if we have better alternatives. And so being able to just release a better product means better, utilization of it. And so it just makes business sense, which is why my skeptical before was in response to altruistic stuff.
Mm-hmm. I would also not underestimate how much prior art there was and how much like it was sort of obvious to people that you had to push in this direction.
Totally.
WebRTC is not a standard where they were like, oh, we have this use case, like real-time video. Let's create something from scratch or create something designed for the web or something that is like really like from our values. It was literally, like WebRTC is built on top of RTP, which is like this protocol stack on top of UDP. And like I was working on RTP at Real Networks in 2003. Like it's an old technology that has been around for a long time to try to do low latency video and audio.
Yeah.
Back then over like what would now be called feature phones, but back then was just phones.
Was that Real Player?
Yeah. Like we were doing mobile video in 2003. So on like these little like Nokia phones, right? And so you had to push that over UDP. You had to have a protocol stack that could handle that. And that was where a lot of the early RTP development happened. And then that had matured until like 2011. And so WebRTC was, basically a web API slapped on top of this RTP stack and a bunch of other technologies that had kind of already been worked out. So much so that one of the reasons why it's like not all that performant and has a lot of other problems is because there is just this huge protocol stack that there aren't many implementations of, and the browser vendors just kind of like took and built their thing on top of.
Right. So if the specification began obviously building on the shoulders of giants or prior art, like you said before that, but then it started around 2011. Feross heard about it in 2012. The official 1.0 release was about 2 years ago. So the question that I always have, especially with technologies which feel new or feel like they're not used all that often, is can I use? And so what's the state of the world with WebRTC today? We're going to talk about like the intricate details, but like, can we just use this somewhat willy-nilly and just expect it to be available in all the browsers?
So I think you can pretty much just use it. I think that the one place where you run into a little bit of trouble still is on Safari on iOS. Safari was one of the most recent browsers to get WebRTC, and I'd say their implementation is still a little bit buggy, especially on iOS. there's just a bunch of unnecessary kind of limitations to the implementation on that platform. Like you can only request the camera one time. If you request it 2 times, you want 2 streams, maybe one in a higher quality, one in a lower quality. The second time you request it will just kill the first request and you'll lose that stream. Just stuff like this. You get stuff where like you'll get a phone call in the middle of a WebRTC call, and then when you end the call, you go back to the browser and your stream is dead,
just gone.
Yeah, or like you put your AirPods in, and then now you lost your audio. It's just like all kinds of like really anything that's basically not the happy path. You get weird bugs on iOS Safari, but I will say I do know that they're actively working on it. And the main problem is I think they're just kind of an understaffed team. Like there's like basically one person working on it, and he's very actively fixing bugs, but it's just there's a certain rate at which he can do it. And I've been testing out the iOS 14 beta, and it's a lot better. So I think by the end of the year, you won't need to do as many hacks to get it to work on iOS. But yeah, I would say that's probably the main reason why you see people doing native apps still for any kind of video conferencing or voice stuff.
Also, I would say that just the quality is not going to be consistent between browsers. So it's always going to be there in most browsers, but the quality in general is not going to be there, especially for video and audio. If you're doing the data channel, it's a little bit more consistent. But also something to be aware of is that the service that you use to set up the connection, this stun turn server, if you don't have it set up to proxy data through that server, you're going to have, what is it, Feross, maybe 10 to 20% of the people that you try to connect to not actually be able to make a peer-to-peer connection, that you just can't get whatever kind of port forwarding or whatever network issues are there. And so it ends up falling back to just routing through that server. And so unless you have a server that you're willing to pay the bandwidth on for those users that can't actually make a proper peer-to-peer connection, the reliability is going to be not as high as you would want, right? Like that's pretty far away from 100%.
Gotcha. Sounds complicated. Well, let's turn to the happy side. There's lots of cool stuff you can build with this technology. And we all know the obvious ones are like Google Hangouts, right? And Zoom uses it, and like pretty much anybody doing video conferencing uses it in some capacity nowadays inside web browsers or inside quote unquote native apps, which are browser based technologies inside the native apps.
Actually, just to add to that list too, Jerod.
Yeah.
Pretty much any native app that you see that has video and voice is using WebRTC, even if there's not a browser involved at all, because the WebRTC library is like this C++ library that you can just download and include in your app. So basically, like almost every iPhone app,
like something like FaceTime.
Yeah, FaceTime, Facebook Messenger. They might not be using the exact, they might have tweaked the code a little bit for their own preferences. Like maybe, they tweak the way the video works a little bit or something, but basically they're all using the same stack, which is WebRTC, even if there's no browser involved.
And there are React Native bindings for that, ironically, as well. So
really?
They use the iOS bindings in order to create the library for the React Native.
Turtles all the way down on that one.
Side of things,
wow.
Which is super interesting. Yeah.
Yeah.
Wow.
So is there an alternative? Like, is there a non-web? Is RTP, real-time protocol, is that still a thing? Are people using alternatives, or is it just like WebRTC took over the world?
It's more like there is a set of new protocols that are better at all of this stuff.
Yeah.
But what's probably going to happen is that the WebRTC interfaces are just going to be moved on top of those, right? So Quick is the underlying protocol for HTTP 3.
Right.
And it's phenomenal.
And it's all on UDP, right?
Yeah, and it's so nice.
Still scares me.
Yeah. Somebody that I work with actually, who I manage now, like works on the Go implementation of Quick, and it's a phenomenal protocol, phenomenal standard. It's really coming along really quickly. There's also a specification where people are thinking about and trying to work through what it would take to just put WebRTC on top of Quick. So it wouldn't be HTTP 3 on top of Quick, it'd just be WebRTC on top of Quick. And that'd be great. But that's a little ways off, probably.
Yes, and we're definitely getting ahead of ourselves as well. So let's talk about cool stuff people have built with WebRTC. Present company included. I know that y'all have built some stuff, even if you no longer maintain that stuff and you don't want me to link to that stuff. You built some cool stuff. What are the kinds of things? I know it's not just video. There's peer-to-peer file sharing. There's audio applications. There's games. Like what's cool stuff that's out there?
I feel bad because the stuff that I'm going to talk about is partially something that I worked on at Microsoft. I hope that's okay.
It's totally fine.
Of course.
There's a project called this 3D Streaming Toolkit, and this is something that I worked on during my time at Microsoft because of a customer need. Essentially, it uses WebRTC with virtual reality and mixed reality devices, and also mobile phones. So let's say you have someone with a low power Android phone who's trying to use Google Cardboard, or let's say you have a HoloLens, which the entire processing unit is actually in the headset. So it's not connected to some super high powered PC, even though the HoloLens is actually a pretty performant device. Let's say you're trying to kind of like manipulate lots of polygons in space. It's either a complicated game or it's for a medical application, such as being able to kind of rehearse or understand some surgery you need to perform before you actually do it. A lot of these devices are just not going to be able to crunch those polygons in real time. So something that I worked on is called the 3D Streaming Toolkit. And what essentially it does is there's a central server that you have a WebRTC like peer relationship with, and you're able to stream in real time. It will render the 3D based on the data channel feedback you're giving it on pitch and roll and, you know, how you're actually using the accelerometers on the device. And it is so fast that you don't get that motion sickness because the feedback and the data channel going back and forth and saying, okay, this person's now moved their head this amount. It's able to do enough look ahead and prediction as well in order to render 3D video in real time and stream that back through the video channel back to the VR device. I hope that I've done that explanation justice, because obviously there were a lot of details that went into this, but I worked on the web client sample, even though my name is not in the commits. I was pairing with people on that. So that was a really exciting thing to see, because it means that people don't have to have these really high-end expensive devices if you can use this protocol in this way, which I thought was really cool.
That is an awesome. That's cool.
super, super cool.
Yeah.
Can I ask a question about it?
Mm-hmm.
It's incredible that you could like send the position data for your head over a data channel and then have it like render a video and send the video back to you over the data. Is it also back over the data channel for the video?
No, I think the video is the video channel.
Oh, okay.
I'm trying to remember. I actually could be wrong. It could have been all through the data channel as well, but I don't remember just because it was a few years ago that I worked on this.
Wow, that's super impressive. I was wondering though, like, it seems like the data channel, like it seems like you used it mainly because you wanted a UDP type connection to the server. Is that right?
Mm-hmm. Yeah, that's what a lot of it was. So it wasn't necessarily that there were bits about WebRTC like holistically that made it make sense. It was really just a lot of the low latency stuff. I think it's a very novel use case for it because you wouldn't really think to couple this kind of thing with WebRTC, which is why I thought it was particularly cool.
That is cool. That's really cool. Unfortunately, that might be the coolest one. So all these are all going to sound lame.
That's not true. That's not true.
All right, Mikeal, top that. Come on.
So I feel like there's sort of two buckets of projects that I see in WebRTC. One is like kind of obvious. This is the only peer-to-peer protocol in the browser. So if you want to do anything peer-to-peer ever, you have to use this. Okay. It's not like you can just open up a port and do something else, right? Like you could if you were just like running on Linux. So there's a lot of projects that are in that category, and I'll talk about those in a second. But one thing that I started exploring a few years ago, and it's not maintained, so don't link to it, is like one of the cool things about this technology is actually that it's in the browser, and so we can start integrating other browser technologies and other audio technologies into it. So I did this little thing called roll call, and basically it was just like an audio only thing because video is too unreliable. But what would happen is like the audio for each person would come up and, I was using Canvas to render, the levels of each person as they talked, right? Similar to you would normally see like in a multi-track audio recorder. You could drag and drop files into it and play those files into the call. That was like a cool thing that you could just do with the audio element. The media recorder API had just come out, so you could actually record the media. So what I did was I used that to record everyone's individual audio and send that through the data channel to the host of the call, right? So like something we do when we record this podcast is everybody records their local stream on QuickTime.
Right. Local recording.
Yeah, and then we drop it into Dropbox. So this kind of automated that.
Upload it through Dropbox. Yeah.
All right. Exactly. So this automated that. It actually took everybody's local track. So you could record like a podcast and have the WebRTC audio be like the monitor and then but still have the multi-track at the end. So it was like a really fun experiment and pushed a lot of things together. But it's not maintained anymore. A lot of stuff has changed since then. I don't think it works.
So we won't link to it. You might be able to find it out on Michael's GitHub, but
yeah.
Don't open a pull request. Well, Mikeal, I remember when you were writing that, we were hoping to use that actually for our podcast, and it was experimental. And I was just always curious, like, were there limitations that made it just not quite get there? That's how I think a lot of WebRTC things are eventually. It's like, well, it wasn't quite there.
One thing that you figure out really quickly, right, is that if you're taking in all of these high quality audio channels and you're taking them into one of the peers who is the host of the call, while the call is going on, then there's not enough bandwidth for the actual audio quality to be good. So you can really saturate your connection really quickly. So what you actually want to do is just buffer that kind of locally and then send it at the end of the call. But then if somebody closes the browser, then you don't have the audio. So actually what it turns out that you want to do is send this to a server. This is actually a place where a central server would be quite nice. And there are some products now that do this really well, where, it's using a real-time audio channel, but then sending all of the background channel to a server. And then at the end, you'll see that it's like, no, don't stop yet. We're still uploading. So there's some UI around that that's really nice. And I never really got to that part of it. And I looked into solving some of those issues with some other technologies. I looked at potentially using WebTorrent to do the file portion of it, and that didn't quite work. So I started looking at IPFS, and at the time, this is 3 years ago, IPFS wasn't quite ready. The next kind of bucket of projects, right? Like the peer-to-peer projects that use this because it's the only thing to use. There's a lot of cool stuff in that category, right? So Feross talked about WebTorrent, and WebTorrent's amazing. IPFS, something that I work on a little bit. It's really nice now. It uses that channel as well. And then IPFS is really built on some primitives that also take advantage of this. So I work on IPLD, which is the data structures. And we don't do anything specific with WebRTC, but if you want to take our data structures and decentralize them, you would have to use WebRTC in the browser. The whole networking layer behind IPFS is a project called libp2p. And this is really like a peer-to-peer networking stack. If what you're looking at is the whole problem of peer-to-peer networking and sort of content discovery on a peer-to-peer network, and if you want to run this, in the browser, in Linux, everywhere, in every kind of environment, you're going to need all these kinds of fallback logic and all these different protocols on different devices. And you're going to have to think about this in a much bigger way than you would if you were just targeting one system. That's what libp2p kind of does. And so, if you have that whole problem, it's a really good project. I think that if you want to hack together a cool little web project, it's a little bit heavy for that one thing. Mm-hmm. But like Ethereum 2 is going to be built on top of libp2p because they have this whole problem, right?
Right. So where does libp2p sit in a stack, a peer-to-peer stack, with regards to WebRTC? Underneath it, it's completely distinct from it?
No. So WebRTC is one of the potential protocols that you would use in libp2p.
Gotcha.
And you can use other protocols as well. Quick is one of the protocols that you can use in libp2p.
Gotcha.
One of the things that we should really talk about is if you're used to writing networking code on regular systems, you take your IP address and your port and you say, hey, connect to me on this IP address and this port. Doesn't work well with port forwarding. There's some issues with port forwarding.
Right.
But for the most part, you have this permanent identifier, right? I am going to be on this thing for a long time. Here is how you connect to me. And one of the ways that BitTorrent solved a decentralized kind of discovery was a distributed hash table, a DHT, where people take my IP address and my port and they shove it into this table for a while and they say, hey, I've got this content. You can connect to me. WebRTC can't really do this. The way that WebRTC works is that you effectively ask it sort of for almost like a connection token. You can think about it like that. And that's one-time use. And you've got to give that to somebody else. And then they give you a token that is specific to that pairing. And then you use that to connect to them. And this behind the scenes, there's all this stun turn server stuff, and it's very complicated. And Feross can talk a lot more about how painful this can be, I'm sure. But the main thing is that there isn't really an identifier that you can put into a distributed hash table or DHT where you say, hey, this is how you connect to me. Because in WebRTC, these are ephemeral connection identifiers. And so there's a bunch of other problems that you have to think about solving in terms of peer discovery if you're using WebRTC in addition to other protocols.
What up, party animals? Here's some news that you may not have heard yet. Gatsby now has a partnership program. If you are building Gatsby sites for clients, or you're not yet, but you wish you were, you can now grow that with confidence by getting support and resources directly from the Gatsby team. Become a Gatsby certified partner today to accelerate your growth alongside their amazing ecosystem. Get exclusive access to Gatsby's product roadmap, beta test new features, access training materials, and connect with the Gatsby team. There's a whole bundle of partnership benefits. The sky's the limit, so check out Gatsby's partnership program using the link in the show notes or point your browser to gatsbyjs.com/changelog. Once again, there's a link in your show notes or gatsbyjs.com/changelog. All right, we are now going to do a WebRTC primer, but we're going to do it as a team. And we're going to build on each other's technologies, just like WebRTC builds on technology. I don't know. Feross is going to explain something, and then he's going to pass it to Suze, and then she's going to pass it to Mikeal, and hopefully it's good. But if not, at least it was fun. Otherwise, it would have been boring. So here we go, Feross. WebRTC in a nutshell, starting with Feross. Go ahead. Primer us.
So I'm going to start at the absolute lowest level. So we're going to go all the way down the stack to IP, or the Internet Protocol. So I'm sure most people have heard of an IP address. And so that's the level we're going to be operating on here for the beginning here of my explanation. So what is IP? IP is basically a way where you can take a message, a packet of data, and it's kind of like an envelope. You can sort of stamp a destination on the outside of the envelope and say to your router, hey, please try to deliver this to this IP address. And every computer on the network, every device on the network is assigned an IP address. And the internet as a whole sort of just tries its best to route these little packets of information to the correct destination based on the IP address. Okay, so that's the lowest layer. And then on top of that, there's two main protocols that people have sort of added on top, which are called TCP and UDP. So TCP is the more common of the two, and it gives you a bunch of nice sort of reliability enhancements on top of IP. So you can sort of, as an application, say, I want to send like this giant chunk of data. In fact, too big to actually fit in a single envelope. And your operating system will split that data up into little individual packets of information and send that across the internet. But it will do a bunch of nice things like stamp little number sequences onto each of those so that the recipient can assemble them in the right order.
That's so good.
Yeah, and it also ensure that if one of the envelopes doesn't arrive, that there's a way where the recipient can effectively ask the sender to send that data again, right? Something like that. Speaking really high level here. And so anyway, that's TCP. And that's what most applications use. And then there's this other one called UDP, which is like really simple. It's basically like, it's just like IP almost. You just sort of, you stick an envelope in the mail, maybe it'll arrive, maybe it won't. It adds one additional concept on top of IP, which is the idea of a port. So a port is just like when the recipient gets the packet and they open it up and they look at the data inside, there'll be a little port number attached, which says effectively which application on my computer should this packet be delivered to. And the operating system will, based on that port number, deliver the packet to maybe the web server on your computer or the mail program on your computer or some other program on your computer. And that's basically what UDP is. It's a really light layer on top of IP. So where I'm going with this is just that these are basically what all the applications that we use are built with, right? And for many years, this was how, like, this is how you had to build, when you're building a native app, you want to have it talk to some other computer, this is what you're going to do. The problem arises when you start to think about the browser, because in the browser, you don't necessarily want random sites that you're visiting being able to send packets in this manner. Like, I'll just give you one really simple example to think about why maybe you don't want this. All the devices on your home network have IP addresses. And so if you go to a site and that site could send just arbitrary packets to any IP address, one of the things that could happen is, say your printer is on your network, an ad on a website that you're visiting could send some packets to your printer and cause some pages to start coming out, right? That's just really unintuitive for people.
Free coupons.
Yeah. And so basically, the sort of boundary that has historically been in place here is that if you install an application on your computer, you're trusting that application to be able to do TCP and UDP. You sort of said, I trust this thing. I'm going to let it talk to devices on my network. I'm going to let it talk to computers on the internet. No problem. But in the browser context, this is just because of historical reasons. All these printers and all these different devices have been built in such a sort of insecure way. They assume that if somebody can send the packets to the printer, well, then they must be a trusted person because, hey, they got on the Wi-Fi network and they were able to, send me packets. And so because of that, we had to basically invent a whole new thing for the web to be able to make connections in a safe way. And that's where WebRTC comes in. And that's where I'll turn it over to Suze to go from there.
Very nice, Feross.
That is a beautiful handoff that dovetails nicely into signaling, which is a concept for WebRTC that is set up in order for this trusted communication to happen. Is that right for us?
Mm-hmm.
Cool. So signaling is basically the process that happens right at the beginning when two peers are actually trying to connect to each other. And these two peers might not even know of each other's existence at this point. And so it really, signaling concerns the session control messages in order to help set up the session, and also for things like peer discovery as well, right? And stun fits a little bit into peer discovery as well. I might hand to Mikeal Rogers for that later, but we'll go back to signaling. So if two peers want to connect, they need a way to be able to communicate a couple of different things, right? They need to be able to say, like, where am I on the network? Like, what is actually my location? And then on top of that, they need to say, well, I have X, Y, Z capabilities. So I'm able to do video, I'm able to do audio, but I also want to receive audio and I want to receive video. Now, you can have any combination of those things. So signaling is a way for you to describe yourself as a peer, and that goes up to what's called a signaling server. So the signaling server is able to help with these initial kind of session transactions, and it's responsible for basically allowing that trust, that first handshake, I guess, as a way to happen so that two peers have all of the information they need about each other in order to start a direct communication with themselves. And the aim is for the signaling server to only be really just facilitating that end result, which is the peer connection. So the signaling only really happens at the beginning, where you're telling the signaling server, hey, I'm a peer, I want to connect with these capabilities, and I'm able to do X, Y, Z as well. And once it's kind of helped those two peers connect, the signaling server is not part of the relationship after that, right? So it's just responsible for that beginning part. So it's just really allowing you to register yourself as what's called a candidate, which is, I want to be considered as a candidate to have a peer connection with another peer. So that is one specific external server that you need to actually maintain. There are public signaling servers that you can use, I believe. Again, they don't really have SLAs. This is where we're going to talk about production and scaling later. Mm-hmm. But you have options. You can either set up your own signaling service, or there are other public signaling services as well. But you probably don't want to use an actual public one in production. It's really just for messing around. But there is kind of a problem when it comes to signaling and trying to communicate your IP addresses. And that is that networks can be really, really complicated, right? And so you can basically, like, network translation is a hard problem. And sometimes it can be difficult to actually glean what IP address a peer is actually behind. And so that's where stun servers come in, right, Mikeal?
Very nice.
Yeah. I mean, yeah. So turn stun, the entire system, one of the reasons why it works so well is because it's a foreign server, it can look at the request that you send it and go, oh, this is what this person looks like on the internet. Not what they look like to themselves, but what they look like on the internet. Mm. And then you can figure out, like, oh, do I need to do port forwarding? Do I need to do NAT hole punching? There's all this crazy stuff that you have to do behind the scenes to actually get the connection out. And then so what you get from that service is, like, you know, all this information about, like, oh, this is what it would look like to connect to me, like set up, you know, get ready for this kind of a connection. And then if it can't make that connection, if you actually can't connect directly to these peers, it can act as like a proxy between those two things and let everybody through. And that's kind of like at a high level, like as much as I'll go into that. Because there's something else interesting that happens once you have a connection. Like, all of this is prelude to, like, actually connecting to a peer. Right?
It's exhausting.
I know. But once you actually have a connection to a peer, now I have to send data. Feross talked about, like, the difference between TCP and UDP, right? And TCP guarantees that I get all these packets and UDP doesn't. And there's actually an algorithm and a protocol for deciding how to retransmit those packets and when to retransmit those packets, right? And it ensures that all of them arrive. So the cool thing about doing this on top of UDP, right, is that if you're streaming video and audio and you've actually lost the connection, you can say, don't bother sending me all the things that I already dropped. Just, like, please just start sending me the new things.
Keep going. Yeah.
Like, let's just give up on the old data. Let's just take the new stuff, right? So that's like a really important aspect of that. But there's a bunch of other stuff too. TCP does not have like a pluggable algorithm for how it decides how to do retransmission. So even in like a data channel where you do want all of the data, there's things about TCP that are actually not that great. If you've heard of TCP fast start, the way that TCP works is that you just sort of like send packets as fast as you can until you see a packet loss. And then you sort of back off, and there's an algorithm to figure out like how much you should back back off. But that algorithm was written like in the 80s, like the 90s maybe. We did not think that networks would be this fast. And so TCP fast start is like, hey, let's ramp up a bit faster. Like networks are faster now, let's do that quicker. But also only looking at loss is somewhat problematic. Like there are networks, like these things called mobile phones, where one of the things that the mobile phone networks do is that they actually buffer these packets. They keep them around even if they can't retransmit them to try and help these connections that are kind of going in and out. But nothing but loss is visible to TCP. Right? It doesn't see that the round trip times for these packets are actually getting longer and longer and longer because some mobile network is buffering them. So you get really poor behavior out of those algorithms. And so UDP and a lot of what the RTP stack behind WebRTC does and a lot of what Quick does is it comes up with a lot of new algorithms and new factors to look at in designing how you do the congestion control and how you really optimize the speed of the data, whether you want all of it or not. Right? So that's in a nutshell how all that stuff works.
So if you were to differentiate and describe stun versus turn, what are those things? Mike.
Oh.
Okay, Feross. Mikeal looks away.
No, go to Feross. I'm trying.
Something's over there.
I'm trying to remember which one is stun and which one is turn right now. So I think that Feross should probably do it.
Totally.
Okay, Feross, go ahead.
So stun serves two purposes. Okay, the first is what Mikeal said already. You send a packet, your browser sends a packet to the stun server, and the stun server responds with a single thing. It just says, this is what your IP looks like to me. You know, and this is useful because of what Sue's mentioned already, this network address translation or NAT thing that is going on. And that's sort of the way that most people's networks are set up. And so I kind of lied when I said every device on the internet has an IP address. It turns out that like IP addresses became kind of scarce. And so what people ended up doing is your internet service provider gives you an IP address for your whole household, but you might end up having 4 or 5 devices on that Wi-Fi network that are all sharing that single IP address. And the way that happens is that all your devices are given sort of fake IPs by the router, and they believe that that's their IP address. And then when you send messages to the router, you actually say, this is my IP address, but the router's like, I know that that's not really your IP address. That's a fake one that I told you to believe. And so when the message actually goes out to the true internet, right, it has to rewrite that and translate that in the packets that it's sending out. And that kind of messes with everything. It kind of breaks everything. And so now when you're trying to tell the peer you're trying to talk to in WebRTC, hey, this is my IP, you can connect to me, your own computer doesn't even know its own IP address. It's been lied to, basically, by the router. And so that's what stun is for. Stun is like, I send a message to the stun server, and the stun server says, this is what your IP looks like to me. And now you've been able to discover that, right? And then the second thing stun does is that act of you sending a packet out to a server opens up a little hole in the firewall that's in the router. And that hole stays open for a couple minutes. And during that time, the remote peer who you're trying to talk to can actually send packets that go through that hole and reach you. And so it kind of, it does this thing called hole punching, or, you know, opens up a little like temporary hole in the firewall to let stuff in. And so that's what stun is for. And then turn is relatively simple to understand. Turn is like, if all these things fail and somehow, even after doing this hole punching and doing this whole process, we can't connect to each other, and then we give up, then we basically just go to this other server and say, look, like we couldn't connect directly to each other. I'm just going to connect to the turn server. The other person I'm trying to talk to, the remote peer, they're just going to connect to this turn server like it's any other web server on the internet, which you know you're always pretty much allowed to do. And then we're just going to like send our data to that server, and it's going to relay it. It's like a WebSocket server or something.
It's like a proxy. So that's the case where Mikeal said 10 to 20% of the time that has to happen for some reason.
Yeah, and talking about WebSockets, actually, like when you have WebSockets, if that WebSocket handshake fails for any reason, a lot of libraries have built in like polling or like some other kind of way of communicating, right? So in the same way in WebRTC, we have to have a fallback as well, because like networking is hard. And so technically, if you're going through a turn server, it's not really peer-to-peer anymore. You have some proxy in between. All of these servers are actually very simple in what they do, other than signaling is kind of, I don't know, I feel like that's the most complex one. But really, like they all have a role and they're simple. It's just because the abbreviations are really hard. Like turn to me doesn't sound like the fallback one at all. Like turn sounds like signaling, because you're taking turns to say whether or not, like, you know, whether or not your offer is going to be answered by someone else and accepted and things like that, right? And so I always used to screw that up all the time.
Should be like a help server. Like, help me out here.
The way that I remember is that turn has an R in it, which stands for relay.
Oh, yes, I've been told that one too. That's very clever.
So in a hypothetical IPv6 world where where addresses are plentiful and every device has its own address and NAT is a thing of the past, which maybe it wouldn't be. But in that world, is a stun server unnecessary then?
Yeah, I think so. Yeah, because you don't need to be told your own IP address. You already know it, and you wouldn't need to poke a hole in a NAT because there is no NAT. Yeah, so stun's entire purpose would be gone in that world.
I also just want to correct myself. Again, I get confused over all the servers. So you can't really have a public signaling server just because there's just peers flying around and you don't know who they are. So I need to correct that and say you don't necessarily have public signaling servers you can rely on, but you do have stun servers that are public. So yeah, I just wanted to correct that as well. I forgot that signaling is more of a private thing. So there are commercial offerings, but most people just roll their own signaling because there's not a lot of traffic.
Also, one thing that we should note really quickly is that in your JavaScript code, when you get these signals back and you have to do something with them, you really need to make sure that you don't leak those signals and that you don't post them anywhere publicly that people can see.
Yes.
Because private information is inside of those signals, like the internal IP address of those people.
Oh, really?
Yes. Because like the internal IP address is important for the hole punching part.
In order to keep that connection open.
Well, just to start the connection, actually. The signal is just there to start the connection. So like, a lot of people have set up signal exchange servers. There's a bunch of different projects that different people have done, like in the Node community, for instance. And a lot of them just exchange these in plain text. And so the server can actually always look at every single individual internal IP address. And that's kind of a problem. So what you really want to do is come up with an identifier for the peers that you're talking to that's like a public key. And then you can actually encrypt that signal and send it through a signal server without the server being able to see that private information.
That makes a lot of sense. So like easy, right? Everyone's going to go out and implement all this stuff. Yeah.
Linode is our cloud server of choice. Grab the Nanode plan for just $5 a month, just $5. That gets you a gig of RAM, a blazing fast 25 gig SSD, and 1 terabyte of transfer. Let's be honest, you can go a long ways on that $5. When you do need to scale up, their prices are predictable, so you can put your calculator down. You won't need it. We've been running changelog.com on Linode for years, and we've always impressed by their award-winning support team. Check them out at linode.com/changelog. Once again, that's linode.com/changelog. All right, so that was a deep primer. Let's talk real-world production grade WebRTC gotchas, experiences. Feross, you have WebTorrent, which is an excellent example of something that's been out there in the wild and for a while, and millions of people are using, which uses WebRTC. Can you tell us a little bit about that?
Sure, yeah. So WebTorrent is a implementation of BitTorrent for the browser. So basically, it's a user of WebRTC because of what I was mentioning before, where you can't really open up a socket to do TCP or UDP in a browser.
Right.
And so with WebRTC, you can actually get this peer-to-peer connection going on. And this means that, you can do something kind of like imagine a YouTube site where when you're watching video on the site, you actually can share that video with other people who are watching the same video as you. And there's actually a great project I want to call out called PeerTube, which is doing this today. So if you want to host your own YouTube site, you can go to PeerTube. You can go download PeerTube and run it on your server, and then upload videos like you would to YouTube. And when people are watching the video at the same time, it'll try to use peer-to-peer whenever possible. And that's actually powered by WebTorrent. So that's like an example of something really practical that people are doing with WebTorrent today. But more generally, you can sort of share any kind of data over WebTorrent. And the way it works is it uses basically all the parts we've already discussed earlier. So it has, the signaling part, it has the stun part, and basically want to get all these peers that are interested in some piece of content to be able to find each other and to connect to each other. And so, we have the signaling server where you basically tell the server, hey, I'm looking for this file. And that server keeps track of who's looking for which files. And so when somebody else comes along and says, hey, I'm looking for this file and it's the same file, then the server can introduce those people to each other through that signaling process that Sue's described. And then now the peers can get directly connected. And once they're directly connected to each other, they can sort of send whatever data they want. And that part is handled in the way that traditionally BitTorrent is handled, where you you send a piece of the file to the person, and then they verify that it's correct, and then you ask for a different piece, and they'll send that piece to you, and you trade pieces, and eventually everybody gets the file. And then you can go read about BitTorrent if you're really interested in how that works. But yeah, that's basically what WebTorrent is. It's a real world application that's using WebRTC. And it's interesting. One thing I'll say really quick is just that WebRTC is this big jumble of things that people can kind of confuse. There's a lot of parts in it. So one part is it gave access to the webcam and the microphone in the browser. Mm-hmm. That's actually not used by WebTorrent at all, right? We don't use the webcam or the microphone. So that's one thing that people were really excited about WebRTC for. And you can use that part. You could build something where you just get the user's webcam and you just do something in the canvas and you don't even talk to the internet at all. There's no peer-to-peer involved at all. There's no networking. It's completely like a local web app. So that's one thing. But then there's also this other part where you can do these peer-to-peer connections. And when you're doing the peer-to-peer connections, there's actually two sort of ways to do that are embedded in that. One is to do video and voice calling. And in order to pull that off, the browser does all this fancy stuff like figuring out when to like lower the quality of the video or when to like give up on retransmitting parts of it or sort of all this codec and video magic, right? And that's another part of WebRTC that we don't even use at all in WebTorrent because we don't care about, we're not doing live video, we're not doing, lossy, video transfers. The part that we use is this third thing called the data channel. And that part is just like a WebSocket, but it's between two browser tabs, basically. Mm-hmm. And over that socket, you can send any kind of data you want, and it's sort of going to pop out the other end, and it's going to be sort of exactly what you sent. And so with that, you can think of it like it's a socket, or it's a WebSocket, or it's a TCP socket, but it's actually in the browser between two tabs. And so that's all you need to basically build something like BitTorrent in the browser. Hopefully that makes sense.
Mm-hmm.
So Feross isn't giving himself enough credit here. What Feross did, without politicking in standards for a decade, without bugging browser vendors for a decade, is that Feross is like an individual developer on GitHub, upgraded the whole internet, actually.
Oh, God.
Yeah, the abstraction.
So no. This is very true.
Please explain that.
So in 2013, when this project started, I believe a majority at the time of internet traffic was BitTorrent. Right? Like, I think it was a majority. It was very high. It was like a noticeable percentage. If it wasn't a majority, it was something like 30 or 40%. So this is like a protocol that it accounts for a substantial portion of just what is happening on the internet. And the thing about BitTorrent at that time, and on some level kind of still, it is a protocol that is not compatible with the web. Like, every part of it basically was incompatible with the web. The one part that you might be able to make work on the web is like the torrent file format and kind of breaking up the file. But the actual transport to share it on, they didn't work on WebRTC. The tracker protocol is not a protocol that you could use in the browser either. And so what Feross did is that he took just kind of the torrent file format and then made it work on top of WebRTC and on top of a new tracker format using WebSockets. And so now you have like a web version of BitTorrent that wasn't actually BitTorrent.
But it feels like it. Yeah.
It feels like it. It feels like it. But this isn't like upgrading the internet. This is just like a rad application. Then what Feross did is he implemented all of this in Node. And in Node.js, you can actually talk to the real BitTorrent protocols. You can talk to the real trackers. You can talk to the real network. You can get on the DHT. You can participate in the network that everybody on the internet that is using BitTorrent is using. And what happens when you use his library in Node.js, or when you run the desktop version of WebTorrent as an Electron app, is that you bridge these two networks together. And so now all of the people on UDP are not in a separate, like just on UDP in the old BitTorrent protocol, are not in a separate network from everybody who's in WebRTC. These networks are now bridged together. And this was so successful that they upgraded, BitTorrent actually upgraded some of their protocols to include WebTorrent trackers as a thing in there. Now, if you look at most BitTorrent files, you will see regular trackers and WebTorrent trackers. All the major implementations, even beyond Feross's Node.js version, a bunch of the other main implementations implemented support for all the WebRTC stuff, and they're also bridge nodes now. All of these changes have just been taken into all of the regular BitTorrent ecosystem, and that entire portion of the internet is now compatible with the web and upgraded just because of the work that Feross did. So there we go.
Have we embarrassed you enough yet?
I couldn't blush any more than I am now.
Well, let's see if we can fix that. So my soundboard is broken, but I do have an applause track on my soundboard. It's broken. Let's all just clap for Feross real quick.
Ooh, there we go. Thank you.
Okay,
Thank you, buddy.
he's actually more red now. So that's pretty awesome.
Yeah.
That's got to feel pretty good for us. You upgraded the internet, man.
I feel really good. Yeah.
I mean, nobody ever gave him any money for this, by the way. So
Right.
like, the credit is all he gets.
Yeah. Yep. That's true. The project has been really fun to work on, though. And I mean, I got to meet a lot of people around the world and give talks on this stuff and like made so many connections with people and stuff. So it's been really good for me, even though I haven't made any money, like Mikeal said. So it's been really fun.
I mean, you're fine, but you're not like,
Yeah, exactly.
But for somebody who upgraded the internet, I think that, you would think that there would be some kind of cash bonus.
Yeah.
Well, if you really want to get paid, now you have to downgrade the internet and hold it hostage. And then you just upgrade it again for a ransom.
Oh, don't do that.
No, don't do that.
It is it's impossible for you to research the space and try to at least inject WebRTC into something that you're working on, such as I have a side project that I'm working on that uses WebRTC as like multicast peer, like one peer to multi-peers, which is really another interesting use case. But it's impossible to splunk through open source land looking for something to use without finding something that for us is either his stuff is powered underneath or he's actually written the thing. So I think that's important to call out. So
absolutely.
And Matthias too. Matthias Boost.
Yes, Matthias Boost is like, absolutely.
Yeah. A bunch of his libraries are always in there.
Thank you, guys.
You two, like Matthias and Feross, were very influential on me when I first got into Node because it really made me understand what the community can actually achieve with this kind of stuff. I think it's really awesome.
And actually, Matthias is the one who inspired me originally to even realize that you could do streaming in BitTorrent, because he made this amazing library called PeerFlix. I don't know. You remember that? Okay. Yeah. And it was like, what if we just took the torrent protocol and made it into a stream? So you could say like, just start feeding me the first bits of the file so I can start playing it back in VLC or in some kind of video player. And that was like the first time I had ever seen that. And it was so cleanly done. And so of course, WebTorrent, like I just straight up copied that from his code, basically.
I have memories of him showing this off at NodeConf.eu, which I'm sure all of us, I know that Mikeal was there.
Yeah.
It just felt so magical.
So he did this really cool thing. And I can't believe that this didn't turn into like a company or something. But he did this really cool thing where he would take a Docker image and then share it over WebTorrent and then mount it via Fuse.
Wow.
So here's the amazing thing about this, right? Is that what Feross has talked about, where you would get a WebTorrent thing like as a stream. Something about the BitTorrent protocol is like, as you're getting every part of a file, you don't prioritize one part of the file over another. And then at some point, somebody realized like, people like to just start playing these files.
The beginning is important.
So maybe let's get the first parts first, right? And so what they did was they changed the protocol to get the first parts first. But what Matthias did was he said, well, if you're just requesting parts of the file, let's just prioritize those. So it could really be any part of the file. So when you did this Fuse thing and you mounted like a 4 gigabyte Docker image and you had none of it, it would boot really quickly because all you needed to boot it and all you needed to do to like actually start running it were these very like unpredictable parts of the Docker image, parts of the file system that you would need, right?
Yeah, exactly.
And and so like you could boot these huge images really, really quickly and just kind of fill in the rest of it while it was going. And I still cannot believe that this is not like part of somebody's deployment infrastructure somewhere.
That's amazing.
It's super cool. I still remember the part where he typed like node and hit enter, and it freezes for like 2 seconds or 3 seconds while it's going and getting the part of the file system where node is installed. And then eventually the prompt comes up. And then after that, it's just instant because it's now cached locally. But it's this idea of like just in time fetching the parts of the file system that you need is so cool.
Mm-hmm.
This is actually like one of the points in time where Merkle trees really clicked for me.
Yes.
The underlying data structures that are here for this are called Merkle trees. And so like I had worked on CouchDB and I wrote PouchDB. And one of the problems that I always ran into is like, how do you do partial replication of a data store? Because it's not predictable which parts of it that you would need. So how am I just going to be syncing back and forth this data structure where I don't know which parts that I want? And this sort of demo that Matthias did showed me that like, if you use these Merkle-based data structures, then you can actually just wait for the reads to come in and then just access the parts and sync around the parts that you're accessing in real time. And you don't need to build a sync profile for every user on every device ahead of time. You can actually just wait to see what they do and then make that the profile. There's like a straight line from that to me working on this IPLD stuff now.
That's really interesting stuff. Let's talk about one quick, we're bumping up against our time. Let's talk about one quick, probably it seems like the biggest gotcha. Mikeal, you mentioned it in the first segment, which seems that this turn server becomes a relay for clients that can't connect directly. And so I think a production gotcha that many people will bump up against, and maybe didn't see it coming, is massive bandwidth costs, right? Because you have to host that or pay for it somehow. How does WebTorrent work around that? How do people who run video conferencing things, I mean, do they run their own
I have
turns
that challenge too.
infrastructure? You do?
Yeah, with the
Tell us about it.
the multi-peer.
Yeah, so how do you handle that, Suze?
I bought a really big computer in an Arizona data center
Oh, you did?
that has terabytes of bandwidth every month and a lot of RAM to handle all the peers, essentially.
Okay.
Cost me $200 a month.
Are you serious?
Well, that's not too bad. You're serious about this project then? Are you using it for your streaming, or what's the own it?
Yeah, I don't want to reveal too much, but it's a streaming related thing because I want to move off third-party services to my own.
Gotcha.
No, tell us the IP address. Like, put it out there publicly.
I should do timeshare on it. Honestly, it has like so much RAM. It's not even funny.
Oh yeah, because you're only using it, if you're only using it for your own streams, then it's like tons of non-peak time.
Well, I don't use it now, but I'll only technically use it on Sundays. So like I could just timeshare this or like do research for SETI, and I really should be doing this.
That'd be awesome.
Anyway, sorry, Mikeal.
What about WebTorrent? Is Turn involved there? Or is it just not connect to those peers, or what?
So it really matters what your use case is with WebRTC to decide whether you really need to worry about these peers that can't connect.
Mm-hmm.
So in the case of like a video call where you're trying to, like, let's say do a Google Hangout with somebody, if you can't connect to that person and then it just fails, like that's a really huge problem because from your perspective, the app is just broken, right?
Yeah.
But if you're in a system like WebTorrent where you're trying to download a file and there's maybe like 20 or 30 people who have the file and you can't connect to a few of those people, then it's not the end of the world. So you can just say, oh, well, I'll throw my hands up. I'll just have fewer peers to download from, but it's not really the end of the world. And so it doesn't really make sense for, WebTorrent as an open source project to be running a big relay server for like all these random people out there to be sending their traffic through. And especially we don't really want to be involved in that business anyway, because
yes,
that's not a good.
Yeah, we don't know what torrents are being downloaded and stuff like that. So basically in WebTorrent, we just don't include a turn server by default. But if you really want to, like say you're using, like for example, I'll give you an example. We have this site that we run called instant.io, which is basically a place where you can drop a file and then get a URL and share it with your friend, similar to Firefox Send or something like that.
Mm-hmm.
And it uses WebTorrent behind the scenes. And then that's how it does the file transfer. But in that situation, you really want to make sure that when you send a file to somebody that it's going to arrive, and you might only have one person who's seeding that file, right? Like I'm trying to share it with you, Jerod. And then so you better be able to connect to me, right?
Right.
And so in that situation, you would want a turn server. And so we actually do run a turn server on that URL to help those people, their connections to succeed. But that's not built into the WebTorrent library that anyone's going to just pull off the shelf. That's like an option you add in.
So another production situation that you have is your Virus Cafe application. How are you handling, that's WebRTC, right? How are you handling the turn in that situation?
That's, again, it's just a turn server that I'm running.
So you're just paying the bandwidth costs?
Yep, paying the bandwidth costs.
Well, I mean, if that's the way people go about it, that's what I'm trying to get at.
That's what you have to do, yeah.
Is that prohibitive for you?
No. I mean, in my case, there's not enough people online. I'm paying $5 a month for my server, so I'm not as popular as Suze.
Yeah.
Suze is precisely, what is that, like 80 times more popular or something? 40 times?
When roll call actually worked, it was using Feross's dungeon server.
Oh, that's amazing. Oh my God.
Okay, so it is the buddy system at this point.
Yeah.
Yeah, I mean, managing that many WebRTC peers is very expensive and it uses a lot of memory. So yeah, like 300 peers connected to one peer is a lot. So that's really where my traffic is coming from, really.
Gotcha. Other solutions, I'm sure there's commercial turn providers out there that are probably cheap to get started and then scale up astronomically. So is there a reason you went with the hardware solution versus like turning to a provider? Like I think Twilio has a turn service. People like that.
It's mostly because the live video is powered by WebRTC, but it's not necessarily something that I want to maintain. Does that make sense?
Yeah.
I use a Java application that does absolutely all of that for me. So it's not like, it doesn't actually turn is not super duper relevant, but also like the Java application also provides HLS streams too, which is not WebRTC, right? So like it's a whole package, if that makes sense. So the WebRTC is just the low latency version so that I can respond to people within a second of them chatting with me. That's why it's so important to me to have that low latency. So
awesome.
Sorry, that didn't answer the question, but like I'm just not concerned with that stuff because I have something that handles it for me. But yeah.
Yeah, well, if you don't have a problem, don't solve it.
I'm still going to have a lot of bandwidth because I am still the peer, right? That's multicasting. So I kind of am acting not like a turn server, but I have the same challenges as a turn server has.
That's fascinating. I wonder how much of your bandwidth bill is because of the other stuff that your server's doing versus the like turn part specifically. I would be curious to know that, because in my experience, the like I was paying a lot of money to Twilio when I was using them as my turn server, and then when I switched to running it myself, I'm now running it on like a $5 or $10 a month Linode server. But like I've probably given Twilio like $5,000 or $10,000 over the years for the turn service. Now I'm paying like $5 or $10 a month on Linode. So I don't know why it was so expensive on Twilio, to be honest.
Right. Even with a multicast, 300 peers, 10% of those people need turn. It's 30, right?
That's the thing. Yeah. So you know that I have 300 peers. Yeah. So I have usually on like a good day on Sunday, I have 300 people, but that can spike depending on like if someone like Swift on security retweets me, I had 600 that day, right? And so I've been trying to optimize for up to 1,000 viewers. And I've just been basically setting up ridiculous Kubernetes powered like load testers so that all these Puppeteer instances are trying to connect via WebRTC, and just making sure that like doing a lot of calculations of my bandwidth to make sure that I don't end up going over my bandwidth requirements. And so it's not that it will be a rising cost for me. It's just that I have budgeted $200 to cover what the maximum I probably need. So it doesn't vary. I get like a limit, if that makes sense.
That's super fascinating stuff. Once you go public and are using it, I'm sure I trust you'll be publishing something that we can read because it sounds fascinating, your setup.
Yeah, I plan to write about it because I also had to obviously look at all the cloud providers that do similar things and make a choice whether to run my own. So it's been a very long journey to get here.
Let's wrap this up real quick with some learning resources for folks who are just getting started. Obviously, y'all have been deep in this for a long time, but if you can go, well, Sue's last. Oh, Feross and Mikeal have been deep in a long time. Sue, not quite so long.
Not as much.
It seems like a long time. How did you learn this? And maybe even better question, what's the best way to learn today? If y'all know it, is there resources that we can point people to in the show notes?
I have some beginner resources that I can recommend. First of all, there's a really good WebRTC infrastructure article on html5rocks.com that really, every time I forget all the bits, I just go to that article and I'm like, okay, cool, I remember this now. But if you want something that is less heavy, because that's actually a dense article, even if it is a primer, like, which is just an unfortunate fact of life without WebRTC, there's a really cool stop motion animation on YouTube that is basically, I forget what it's actually called, but we do have a link to it. And it just explains all of these concepts in the most delightful way. And you'll get to the end of the video and you're like, oh, I get this now. And you'll be ready to kind of explore on a deeper level.
Awesome. Linking that one up now. Any others out there for Ross or Mikeal you'd like to point people to?
I agree with Suze's recommendations.
Okay.
I'm pretty sure I've read that same infrastructure article on HTML5 Rocks many times.
Yeah. There used to be like a set of Mozilla demos that they had put together that were like tying WebRTC to other things. I don't know if they've been kept up to date, but I don't have a link to them handy, but maybe we can get it into the show notes. But those were really, really useful for me when I was trying to figure out exactly how to sort of take like a media recorder and pipe it into here, or take like an audio element and integrate it with WebRTC. So when you're doing that part of it, that's really useful.
I'll just add, and I'll be a little bit self-promotional here, but the Simple Peer library that I created.
It's awesome.
Thanks.
Sorry.
Everyone uses it. It's, if you're in JavaScript,
literally everyone uses it. Yeah.
It's basically a way to get started with WebRTC without having to learn all the intricacies of the API. Basically, all the stuff we discussed earlier, all those little steps you have to kind of handle by hand. But if you use Simple Peer, it kind of calls all the methods and stuff for you and gives you a little bit of a simpler interface to it. That's pretty useful if you're just getting started, I think.
If you're only doing data and you really you're concerned with like other languages and other environments outside of the browser, I would point you at libp2p as well. This is like a really massive, complicated problem once you start to get it into the, like, just beyond only the browser. And yeah, they're really kind of taking it all on. And there's implementations in multiple languages that are actually tested to be compatible with each other. So
awesome. Well, links to all of those things are in your show notes. Next week, we have another great show. Mikeal, you want to tease next week's show? You're doing some ES module, your journey to ES modules. You want to give us a tease?
Yeah. So ESM got unflagged in Node.js. And so now you can write native modules, native ESM modules that work in Node in both LTS 12 and also current 14. I've been diving into, okay, now that we can write agnostic modules, what does that look like? What does it actually look like to write code that runs in the browser and in Node without a compiler? Or, and actually I have some code also running in Dino now as well. So what does it look like to actually write code in ESM that can run everywhere without a compiler? And what is the new landscape of tools going to look like on top of native ESM? And it is a bigger change than I think people are ready for.
Awesome.
I think almost 9 months ago, we did a show on ESM. And one of the things that came out of that was like, a lot of people think that they've been using ESM for a long time because they've been using the syntax through compilers. But native ESM is actually a very different thing. And this is going to be like the most disruptive thing that's happened in our ecosystem. Like a lot of what we have on NPM is not going to work well or make the transition. So
you betcha. So that's next week. Fred K. Schott will be joining us. Chris Hiller will be there. And it should be an excellent show, so stay tuned for that one. This is JS Party for this week. Hey, that was a lot of fun. Y'all are super smart on this stuff, and I enjoyed learning from you. Hopefully, the listeners did as well. Thanks, Suze. Thanks, Feross. Thanks, Mikeal. We'll talk to you next time.
Awesome.
See ya.
If you're listening to this in the month of July, you got a shot at some free goodies. We are doing a giveaway in celebration of our friend and open source whiz, Zeno Rocha's new book, 14 Habits of Highly Productive Developers. If you don't know Zeno by name, you may have heard of his wildly popular Dracula theme. It's an awesome dark mode theme for text editors, terminals, etc. And we have free bundles of Dracula Pro and 14 Habits to give away for absolutely free. That's a $60 value, and there are 3 ways to enter. You can be the reviewer, the socializer, and the recommender. Hit up the link in your show notes to get started. There will be 3 lucky winners, and you could be one of them. Thanks to our longtime sponsors, Fastly, Linode, and Rollbar for their continued support, to Breakmaster Cylinder for our amazing beats, and to you for listening to the JS Party. We truly appreciate you. That's all for now. ES Modules next week.
And these are the breaks. Break it up, break it up, break it up.
That was a great primer, guys.
Feross also has a hard time tooting his own horn. Like
Yes.
I feel like after Feross talks, I'm probably going to have to talk and say like how rad Feross is, because he won't.
Yes, I will do the same as well. Like, you guys, this is the Feross fan club right now.
Yeah.
I feel the same way.
Sounds good to me.
I will try to do my best to explain. Oh, am I too far from the mic?
No, you're just blushing.